We're almost there. We've almost got everything that we need to graph any sine or cosine function. The only thing we're missing is the horizontal shift c. Let's consider sine functions first. When we see sine function, for reasons we talked about, you should be thinking this 5-point pattern, 0 max, 0 min, 0, for a positive sine function. Now, if it's a negative function, negative sine function with that negative out in front of the sine, it will be this 5-point pattern, 0 min, 0 max, 0. All right. Well, what is a? I've modeled the sine function with y equals a sine b times the quantity x minus c. What? That's certainly new, plus d. What is a? Well, a is amplitude. Remember, a is going to be in absolute values. It's always going to be positive. How do you find a? It's max value minus min value divided by 2. So it'll be this maximum y value minus this min y value divided by 2. B, by definition, you've got to know this by heart, that is, by definition, the number of cycles or periods. I'm using the Greek letter lambda for that, from 0 to 2 pi. Well, there must be a connection between this letter b and the actual period length. And just a thought, remember this for the parent function, the period here is 2 pi radians. And so the more cycles you have, the smaller your period. And the relationship that encompasses that is period is 2 pi over b. The vertical shift is the average between the min and max. So d is equal to max plus min divided by 2. That's the average. Notice the amplitude has a minus, the d has a plus. It's the average. There's no absolute value here. There is here. We always report amplitude as positive. We've been through all of that. Well, what is this? If I factor out the b, it's a big if, I have to factor out the b, and whatever's left in the parentheses tells me my horizontal shift. Remember, anything associated with the x is a crazy, cuckoo, bizarro, bonkers world. So a plus c actually sends us to the left c units, and a minus c actually sends us to the right. Now, the advantage of factoring out the b is if you have 1x minus some number c, then you can immediately tell how far the graph is shifted left and right. That's why we factor out that b. If I'm thinking about start and stop, the start of this sine function will be b times x minus c equals 0. In other words, I take whatever's in this huge parentheses, whatever's there, and I set it equal to 0. And that tells me where to start this function. Oh, how do I know that? Because the parent function starts at 0. Where do I stop this sine function? You guessed it. I take whatever is the argument of the sine, b times x minus c, and I set it equal to? Where does the parent function stop? 2 pi. So we'll see how that's done later. But that's the mechanics of it. Start, take this whole thing, set it equal to 0. Stop, take this whole thing, set it equal to 2 pi. The idea is exactly the same with the cosine function. The only difference is with the cosine function, you know that the positive cosine function goes max, 0, min, 0, max, and we do that from 0 to 2 pi. That's a positive cosine function. A negative cosine function goes min, 0, max, 0, min. We've talked all about that. A still is max minus min divided by 2, absolute value. Remember, d is max plus min divided by 2. We're taking the average of the top point, the y value, and the lowest point, the y value. B still remains the number of cycles or periods from 0 to 2 pi, and the period is still 2 pi over b. If you factor out this b, I'm going to draw an extra parentheses here. If you factor out the b, then a plus c actually moves you to the left. Isn't that crazy, cuckoo, bizarro, bonkers? And a minus c sends you to the right. And it's the same idea here. Where do you start the cosine function? B times x minus c equals 0. Well, that's where our parent function starts. And where do you stop it? Well, b times x minus c equals 2 pi. Well, no wonder. That's where we stop the parent function. I know that's a little confusing right now. Let's do some examples and see how this all works out.